Are we live? So today, we're gonna do some easier stuff because I need more of a warm up. Want to build up more gradually than some of the other stuff I was doing. Mainly, I'm tired today because I exercised a lot yesterday. Anyway, there's this program in school called 42. It's somewhat famous, and I have a friend who went there, French guy. If you search for this, 42 piscine, piscine means pool in French, so it's like the idea is you're jumping into the pool. So that's the beginning of the program, and you can find the PDFs. And in particular, day 0 and day 1 are, I believe, just shell scripting stuff. So, yep, that's shell scripting stuff. If you're interested in that, if you want to work on your shell stuff, which is good. If you're on a Mac, you load up the terminal and you can start with day 00 here. It's meant to be pretty challenging, so keep that in mind. If you're on Windows, check my video where there's a few live streams ago. It was Introduction to C Programming, and I show you how to get this terminal going. So that's cool, and I show you kind of the basics. So if you want to do shell stuff, you can do those first few days. But we're in day 02 here. Yeah, we get some basic C stuff. So I might just kind of follow along with this stuff. I've done it before. But print alphabet. When was the put char thing? Put char. This is not put char. I think I missed put char. Well, I'll implement my own put char first. We'll start with that. So, I had this C folder where I'm working. I'll do a git status. We're good. Put char. Implementing my own put char. Okay. I'll try to do this kind of from memory. Let me write, let's see, we're not going to have a main because it's just going to be a function. And what's the output? I think it's void. Let me load up one more instance of Ubuntu. So I can get I should be able to get the man page for put char. But it puts a character, but it returns an int here. This really can be a char. I want to get the return information of what it's supposed to return. It says return the character written as an unsigned char, cast to an int. Okay, so it sounds like we're supposed to get an int as input and then cast it to a char. I'm not sure if Can you cast to a char in C? Not sure. I guess we can. But you just put parentheses char, yeah. Like that? Okay. Alright then. Oh. This one. So it should be an int. One, two, three, four. And we take an int, and so we cast it to char. So can I just say, actually I'm gonna go like this, call this I. Can I just say char C equals char I? That's supposed to cast it. I believe that will work. And then we're supposed to use, if I remember correctly, the right function. So if I go man right, the thing is, there's multiple man pages. There's a way to get more man pages. Is it like that? Well, I'll have to man. Okay, man. How do we get more? So thank you for the examples. I need the options. Did I skip over the options? Naruhodo. Konnichiwa. What am I doing? Trying to do some sort of easy C stuff. The programming language C. And there's this school called 42. And the beginning of the school is called Piscine. So I searched for this. And so I'm kind of following their curriculum a bit here. And actually, I believe it was not day 0. Day 0 and day 1, I think, are, yeah, shell script stuff. So I'm on, let me check day 1 real quick. Actually. Yeah, day 1. This is more shell script. Okay, and then day 2 is what I'm on. This is where actual C begins. Let's see. And I believe I need to, so I'm allowed to use this, it says allowed functions put char. I think I need to implement it myself. That's what the FT in the beginning means, stands for 42, and it's meant to be sort of functions that you implement yourself at the school. So that's kind of the idea of the school, is that you start by implementing a lot of basic functions and sort of building your own library. And so if you don't know programming, building your own library just means you're building a bunch of little pieces of code that will be useful. And so yeah, we want to implement this put char to start with. And I believe to do it, I need to, there's something called write. Okay, I'm gonna Google how to get all the man pages. So the man pages are manuals. How to get all the man pages. It's dash K probably. Silliness. Well, that lists them out, I guess. Maybe, oh, whatever. Let's just read the manual for the manual. So dash uppercase K, L, W. I need the options. Can I page down? Yeah. Here's some options. Doesn't list a lot of them, huh? Here's more options. Well, these are just examples. Yeah, that's cool. So what I just did with the K actually searches the manuals for what you typed in. That's useful. How are we gonna get all of them? Now here's the general options. Hooray. Da 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 da. Local where C M S la 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 A all. So it was just dash A. Why did I think it wasn't? I don't know. Anyway. Dash A, right. I realize you can't see that. Okay. This should give all the man pages. So what we'll see is this has nothing to do with C. This is something to do with a Unix-like operating system, I guess. So I'm going to press Q. It should, wait. Okay, maybe I have to push enter. That's why. If I push enter? No. How do I get to the next one? Bruh. How do I get to the next man page? Press H for help, okay. This is programming, right? Basically, sometimes you get a little bogged down. Good lord. How do I get to the second man page? See, I thought Q should have done it. This is madness. Q should do it. What's going on? Oh, okay. I just need to press enter and then... I didn't actually read what this was saying. Okay, enter. Okay, now finally here's the right manual page for... that's related to C. This is the one I want. Okay, and this is what I need to include. This is what I was looking for. So I'm going to copy this. And paste it there. Hooray. This allows me to use right. So, right. So we have int file descriptor. So I think like pushing, I think 1 corresponds to the standard out. It probably doesn't mention it here. But you can always look it up. I think 2 is standard error. 1 is probably standard out. And the reason that this has a return is because it actually might fail, potentially. But anyway. So that's the FD, the file descriptor. And now we have an actual string literal. And then the count. We'll just do 1. We'll see if this works. And C. Okay, also I'm going to copy this while I'm here. And let's see. I'm writing a library, so these are just declarations. And let's just do a sanity check. If I compile my main file and wait, the library. Right. The library is being included. Move this one and put char. Okay. I forget what main is actually doing here. I was working on a bunch of other stuff recently. Oh, okay. So this is stuff I was working on recently on the channel. Well, let's see what main is doing. It's doing this. Okay. So I actually want to use UV put char. Let's see if it'll put a G. So if things work the way I want them to, if things go well, this will output G to the terminal. But there's a fair chance that there's going to be a bug or something. So I'm going to recompile, run the executable, and we have C. Right there. So it seems to be working. I don't know. Adds put char. I'll put UV put char. Cool. And I've set up for this to I've set up a remote repo here in the last stream. Okay. So that's just saving my work. Let's try to get this to be the right size here. All right, that's put char. So the goal was to write the alphabet, essentially. Print alphabet. Create a function that displays the alphabet in lowercase on a single line by ascending order. Okay. So I could have written that to just, hold on, let's UV print alphabet.c. Let's create the file first. And let's make this a little zoomed out. So this is UV print alphabet. I'm just starting with this, but it's going to be void. It outputs stuff, but the output is happening somewhere else. And we're going to include UV, a libuv. So we have access to this. And don't need that. Don't need this. Don't need input either. So I'll just do a while loop. I'll do int I equals 0. 26 letters, right? Well, I is less than 20, and we're going to increment I. Now, we have to figure out what the value of... So if I just put an I here, the problem is that 0 in ASCII is not a letter. The first one that comes up is number 32. So if I put a 32 here, it would print a space. That's the first one. But we don't need to worry too much about it. We can just do A plus I. So I will be 0 to start, and then it just counts upward from there. Let's see, does that look good? Hopefully, maybe. Oops. Sorry, my keyboard is a little confusing. All right. So theoretically, this might work if I didn't make any silly errors. And let's just check this run script that I had before. We're going to have to add some things. So let's just keep using this for now. Okay, maybe I need to do this. Just call it Q equals A plus I. I'm not sure if this maybe is needed. Okay. Conflicting types. Oh, right. I forgot to put here. Just call it C, whatever. It doesn't matter. We'll just stay consistent here. All right. All right. It's not void. But here I'm not returning anything. You're supposed to return C, I believe. If I'm not mistaken. And here it's... This is int. Oh, I have the wrong name here, that's all. Okay, I have the wrong name. Yeah, I got tripped out. Okay, it's outputting C, but main, because main is, that's what main is doing. Print a lot of C's because, wait, what? I'm incrementing. Q equals A plus I. q equals a plus I. It is incrementing. So why is that c the whole time? Does this only run once? No, I bamboozled myself. What is going on? Maybe the debugger might be nice here, but... Can we... I tried to use the debugger the other day with VS Code, and it's giving me trouble. It was not working. Debug anyway! It's not gonna work. See, like, I wish they would let me copy this. Imbeciles. Alright, we're gonna Google that. I'd like to have the debugger in VS Code. That would be very helpful. It won't even let me move the window. Hooray. Alright, I'm just going to type in this error message into Google. The pre-launch task. And what kind of dummies would make it so you can't copy-paste that? Whatever. The pre-launch task, C/C++, terminated with... Okay. It sort of auto-completed that. Delete the VS Code folder. Huh. With pleasure. With pleasure. So if you do ls with the options, whoa. There's a VS Code folder. This is what we do to delete a folder. Try debugging again. Hooray. So if you can get the VS Code debugger working, it's quite nice. But when I was in a programming school, I'd say like 90 to 95% of people had trouble just figuring out how to run the debugger in general. And yeah, that just says a lot. It's not just me. And I wasted a lot of time just getting the debugger to work, like dozens of hours. But because it should be not that hard to get it to work here with just a main.c file. It's when you have a lot of files that it can be a little complicated. So let's try different options here. I'm gonna again remove the folder. I don't think that's the one there. Let's try GDB. We'll try all of them, I guess. I don't know. Okay, launch.json. Save it, I guess. It's genuinely a pain in the butt. Freaking debugger. That's exactly what I love spending my time on. Last one to try here. No, that didn't work at all. Okay, back to Google. I'm not going to spend too much time on this. La 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 la. By default setting, VS Code can compile only one C++ file at a time. Yeah. More of that. So this is why it's annoying. If you're going to have multiple files, you have to do a bunch of crap like this. I would fix it with selecting G++ rather than GCC. Well, we're running C code here. GCC. Bonkers. Then show errors comes up with nothing. Good job, Microsoft. Microsoft sucks. Okay, I'm not going to spend too much more time on that. This is my least favorite thing in programming, is dealing with crap like this. Installed min.gw from a different place. This might be because I'm using WSL. So, alright. What I'm gonna do is make a copy just by dragging it onto my desktop. And it actually doesn't move things by default, it just copies them. So now, hooray, I have a copy. Okay, you can see. I believe I can just drag this into VS Code, but let's see if that works. Yep, that was convenient. Trust. Now I'll try to debug by pressing this thing. Same stupid error. Hooray. But here's what I'm gonna do. Delete this. Let's remove the VS Code folder first. Copy it over. What comes next? We need Visual Studio Code, so just go here and type code. Bring this up again. I think it's in the, it's got the same thing up. I doubt this is gonna work, but maybe. So I'm gonna hit debug. This one. No, sons of bees. Really grinds my gears. We have C and C++ stuff here. This means it's installed, right? Yeah. Okay. What I'll do is I'll use the terminal debugger because VS Code is being a pain. So we have a kind of backup. So this is going to be fun. So to use the terminal debugger, which is GDB, well, it's it's a terminal debugger. GDB is GNU debugger. You actually have to install it. Sudo apt install GDB. I already have it. So, but if you're on a Mac, you might be able to get this with Brew. You're just gonna have to Google it if you want to use it. Maybe the debugger will work for you if you want to do that. I mean the VS Code debugger. And then, anyway, for GDB, we use this G flag. I forget what it stands for. But we need that. And we'll just do main.c. We need some other stuff too. Hooray! One more we need is print alphabet. Thought I had that one. Okay, I'm gonna go to, first of all, get rid of that. I have it set so that I can open VS Code from the terminal. You probably have to Google how to do that if you want it, if you want that ability. And main.c. Okay, I'm just gonna make it so that for now I'm not including my own library here. We're just dealing with the main main file. We need UV put char in there. I'm aware this is becoming kind of a mess, but it's not unusual. You make things kind of messy, then you take the time to clean it up later. It's okay. Especially since I'm not working with other people here. The write function. I think I'm not going to care about that right now. And then GDB a.out takes us into the debugger. And what we want to do, I believe we want to write break main. It puts a breakpoint at the beginning of main. So right when we start, there's a breakpoint. Then we just can do R for run. We can also type it, run. Yeah, I've been getting this. I'm not sure what this is about. So all my debuggers are failing. Hooray! But we can Google this. One of the things they need to do... Oh, this is open, okay. The ones that are closed, they need like a selected answer or something, because a lot of times you have to go through a ton of stuff. All right. Da. Troubleshooting. It's nice that some hack has been found, but this shows a fundamental bug in the way WSL handles debugging traps. La-dee-dee, la-dee-da. Hooray. All right, I'll give this a go. Technically speaking, I should be careful about running this. But I'm kind of lazy right now, so I'm going to do the bad thing and just follow these instructions. Okay, so we're going to remove GDB. Make sure we have this. I'm going to do this in my home directory here. This is just downloading something from the internet. And the tar file .tar.xc is sort of like a zip file. That kind of thing. I'm going to grab a coffee. All right. Okay, what's next? So this is extracting the compressed file, and so this is sort of a I don't know whether to say old school or just normal way of installing something. You download it, and depending on what it is, you have it's very common that you have this like /configure. There's some variations though, so it's really important that people make the information available of how to install stuff. I mean, maybe it's in the README, it's probably on the GNU website, and they're giving it to me, so I'm happy. But over the years, you run into cases where people don't tell you how to install something because they just assume you know, right? And also, I've seen things where you have to scroll way down in the instructions before it tells you that it's only for Windows, for example. That kind of stuff needs to be at the top if it's only for one platform. Anyway, do ./configure. So the more normal way of installing stuff is using the package manager, which is when we do like sudo apt. That's Ubuntu specific. With other distros, they have different package managers. And whatever the hell this command is, it's a make command with some options. And oh, I don't have make. Interesting. Okay, we'll install it. Fans go brrr. Oh. 你好，到了。看下你的来信。祝你生 some very happy something. Hijou teki. 你好。这样开 something 了. You'd think that installing GDB would be a lot faster, huh? We're compiling from source. Right, so we have to compile. Yeah, so that's what this is. So rather than just downloading a binary, we're compiling from source. It's possible... Sorry, this is a little bit obnoxious. It's possible that... so the main Ubuntu package works normally on Ubuntu, but with WSL, so using it on Windows like this, WSL, it's possible there's some weird differences, but if you download the source and compile from source, then it checks for these weird differences and then fixes the problem. That's possible here. Hooray. Let's look at the code for a bit while we're waiting for that. And in fact, let's look at the next assignments or whatever. So print alphabet's not going to be hard. Reverse alphabet's going to be trivial. Print numbers, trivial. Is negative, trivial. Print combination. Okay, here's where we have to use our brain a little. So we'll look forward to that. What the heck is that there for? Anyway. I wonder if this is designed to figure out if somebody copies these PDFs and puts them somewhere, and if the PDF has this, they can know where they got it from, or it's just a random whatever accident or something. So did it finish with the shenanigans? No, it's not done. It's slowing down though. Just checking. Cool. Oh, good lord, we have an error. Good lord. Error 2. This is why I hate programming, to be honest. This all dealing with this kind of garbage. Really don't like it. If I could just program and it would be kind of like doing math, that's when it's nice. Just this stuff. Been dealing with this for the last 30 minutes. Just to get a freaking debugger working. Unbelievable crap. Alright, forget the debugger for now. We tried. I will just check, like, there's a tiny chance that despite throwing this error that I have GDB. And it works. Let's just check. Yeah, no. After all that stuff, we have an error. I've lost my patience for the debuggers. Okay, nothing's working. Forget about it. Forget about it. But why the hell is this not working, though? I equals 0 while I is less than 26. We are incrementing. Maybe... It's so weird. Let's do this. Let's do 256. And let's just put an I here. See what happens. Just a little sanity check. GCC main.c. Everything is C. Why would everything be C? I'm missing something very basic. Why would everything be C? Wait a second. Is my put char messed up? It's very messed up. It's very messed up. That's why. That's what the hell is going on. And we didn't fix it in the main function. Good lord. That's why it keeps outputting C. Now it outputs nothing. Now let's try with Q. Now it outputs nothing. So obviously I'm doing something wrong here. Let's cheat. So ft put char. Oh, we need this. Yeah, we need that at, or whatever that symbol is, and. Okay, cheating accomplished. We need that. Whoa, whoa, whoa. My keyboard is confusing. Okay. So, this is... Let's see what they did. They're not casting. They just take a char. And they're not, and theirs is void. I don't really care about those little details like that. Doesn't really matter. So, should work. Should work. Yeah, we get a bunch of stuff. So it's doing 256 different values here. All we want is 26. Got a headache now after all that crap. Good. It's working. Prints the alphabet. Hooray. Alright, so let's take this and... Well, we'll remove these. Put them over here instead. Coding is scary. How's it going, Milk and Cookies? Did you just start watching just now? Or were you watching the previous stuff? Hello, hello. How are you doing? Turn coffee into code. Alright. We're doing pretty simple-ish stuff here, actually, though. But it's not simple if you're new to programming in C. This one also we're going to take out of here. Put over here, since we fixed it. And main... Just one thing about main, though. We want to switch this back on. Okay. I'm going to edit my run file to have some of the other stuff. I'm going to put main in the beginning. So we have isDigit. We have print alphabet. And we have putchar. Let's do putchar first. Putchar. Print alphabet. So let's test that that works. Yeah. Okay. So going back to the task. Print alphabet, reverse alphabet. That's going to be so trivial to implement. And print numbers is negative. That's too trivial for me. Now, print combination. Create a function that displays all different combinations of three different digits in ascending order. All different combinations of three different digits in ascending order. I think this is a mistranslation because they don't want... When they say it's voluntary, they don't mean that it's optional. They mean that it shouldn't be there. 987 isn't there because 789. Ah. So what's that going to look like? I have to think. Yeah. I have to think. So we're going to have 0, 0, 0, 0, 0, 1, it's like this. And then we're not going to have like that, apparently. But also, isn't this... That's repeating 0 twice, right? Right, okay. It goes 0, 1, 2, 0, 1, 3. Right, okay. 0, 1, 2, 0, 1, 3. And then all through that. Then it'll be 1, 2, 3, 1, 2, 4, and so on. So I think we can. So the sort of inefficient way to go through to do this is to go through all the numbers. I guess this up to 999, and just check. Is that probably an inefficient way. I'm feeling pretty lazy on this one. I might cheat. So let's just look at someone's implementation. Print comb. Print comb. Da-dee-da-dee-da. Oof. Okay. Do we have something more beautiful, perhaps? It's always the same kind of idea. Well, if I weren't exhausted from dealing with the debugger crap, I would give it a proper try. But my brain is a little fried after all that crap. It's really... These things bother me on a deep level. So... And we have another similar kind of thing. Then we have put number. Okay, let's try put number. That actually might be useful, perhaps. So create a function that displays the number entered as a parameter. The function has to be able to display all possible values within an int type variable. Okay, so put number. Is it like that? Void and then int. Okay. Let's call it n. So put number. Okay, so we can use, let's include the thing for write, which it was like this, I believe. So I can use write. My brain is cooked. One way is to like initialize an array that just has a bunch of empty garbage. I think what's the maximum int? It's like 2 billion something. So 1 2 3 1 2 3 1 2 3. So yeah, this will allow us to go into the billions. I hope I didn't make a syntactic error here. I think I can use it like this. I think that this is if you're declaring it, if I remember correctly. All right. For now, let's just try to output the values that are there. So, write. It's going to be like something like this, and then like that. But so let's just do an arbitrary one right now. So char, so we're typecasting, and then R. Let's just choose the third one, which is like that. So all this will do is print the third one. So let's make it no, something interesting. But actually, we need to do... Zero plus, because this will make it the correct ASCII thing. Hopefully that'll work. Let's see. There might be a mistake though. This doesn't. This is just junk. It's not being used. Okay. I think the syntax I used is wrong. It's been a while. Maybe like that. Expected expression before. It's been so long. Can you not initialize arrays like that? I could treat it like a string. Let's just treat it like a string. Okay, so it'll be... But this will be a string literal. God, C gets a little complicated. So billion, 1, 2, 3, 1, 2, 3, 1, 2, 3. Is that right? Yeah, that will be billions. Let's just make some data for the first few. Okay, so this is a pointer, but it's a pointer to a string literal, which means we won't be able to change it. It's an immutable string. We will be able to change the pointer value, but we won't be able to change this data the way it is right now. So we'll have to deal with that problem later. So basically, in a program, there's different sections. It's really just, I think there's some header information sometimes. That's not really important. There's some kind of start function, basically like a main kind of thing, and where you have the code. And then typically at the bottom, there's a data section. This is if you take a program and open it up in like a hex editor, so you can see the actual data. It's what's actually in a program. So there's a data section, and so the string literal is a place in the data section, and the data section cannot change. It's not mutable. So yeah, some programming languages, I think, like if it's JavaScript, I don't think you're ever gonna have, you don't have like these string literals that are immutable like this. But because C is all about efficiency, among other things. So yeah. Anyway, so this thing, and then I think this will be okay. We'll give it a go. I don't know if I've made a mistake again. Okay, so it did, well, it printed C. Oh, because I didn't. C is like cursing me like today. I just want to call this something different. I'm getting paranoid. What is going on? No. It's still C, yeah. It has nothing to do with the letter. 0. What does ASCII look like again? Why am I getting the letter C? Taking 0 and we're adding something to it. Okay, for now, let me just do a sanity check like I do. Suppose that is our thing. Let's change this to C. It's a little silly to call it D. Whatever. All right. And it outputs 0. All right, let's use the first value. A. Went from 0 to A. Oh, right, because this is a char, it's not int. So we actually have to, it's sort of confusing. We do need to make this into an int. Sort of counterintuitively. Then, now we should get 1 here. We get A. Right, because it's still, what the heck? It's not giving us 1, it's converting it into ASCII. This is sort of confusing. Wait, so I don't need to do this part at all. We just do this. I'm like overthinking it basically. Okay, that's 1. I was overthinking it in La La Land. So this is working as an array. 5, 6, 7, 8, 9. Let's just write that all the way through. 5, 6, 7, 8, 9. Okay, so what was the goal? Let's go back to what the goal was. Put number. All possible values within an int. So int goes up to 2 billion something. But we're going to need to be able to do negative numbers as well, I'm pretty sure. We'll worry about that later, I guess. Put number. What was I even doing? Actually, let's do 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. Okay, that's billion. So we're gonna take in this int, and we need to go through mod 10 and like do some shenanigans. It's gonna be reminiscent of this kind of stuff. So let's just pop this in there. Whoa, 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 what happened here? What is this line? What did I do? Did I create 2 windows here? What the heck? Okay, it's gone now. That was weird. Alright. We're gonna have something like this. But I'm not sure which order I should do stuff in. I don't know. We'll just do this first, and if we run into a problem, we'll switch the order. So now let's do the other order. I have a feeling about this. All right. All right. So again, if n were 9 and we do in C, if we do this, we get 0. It rounds down with integers. So if we do this and it's greater than 0, that will mean that it's more than a billion. And in that case, I'm going to hard code this to start. It's going to be the first one. needs to equal this, I believe, let me think. Yeah, just like that. Let's say that it's 2 billion, then we get 2 here. Yeah, this will give us the first digit, I believe. So I'm gonna work with this thing. Alright. We're gonna remove a 0 from both of these. And this is gonna be a 1. We don't need this comment. It's gonna be like this. And now we're in the 100 millions, so 10 millions, millions, 100Ks, 10Ks, K, hundreds, oops, tens. All right. 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Two, 3, 4, 5, 6, 7. But hold on. We also need stuff like this. N equals n mod the thing. That will basically, so if n is 2 billion something, this will remove the 2 billion something, so that when it goes to the next step, you just have the something left over. And we have to do this for all of them. 1, 2. And now I need parentheses on all of these. That's annoying. I'll do that next. 1, 2, 3. I hope there's no mistakes in here, you know? Why does that keep happening? Okay. Happens because that's what I'm telling the computer to do, so it does what I tell it to do. That is how it works. So mod 10, yeah, it'll be okay. Now we need all these parentheses everywhere. Hooray. There were probably better ways to do all this, but whatever. I don't really mind this kind of mundane task, actually. It's vaguely satisfying. That's kind of ugly, huh? Kind of ugly. So, don't need this. Obviously, I have some serious testing to do. Also, at the end, we want to say probably that it equals whatever's left over at the end. Then let's make a little loop that prints everything out. So int I equals 0 while I is less than 9 for the 9 digits. And we're going to increment I forward. I like to do that first because it's easy to forget. Pop this in there. So this will print out all the shenanigans. So theoretically, now I probably made a few errors that have to be fixed, a few bugs, but theoretically, if things work the way they're intended, whatever number goes here gets outputted. Yeah, so let's test it. I really will be surprised if it works in the beginning. And we're just doing positive numbers right now, too. Got to fix that as well. Yeah, seg fault. So it does compile. This would be great to have the debugger, you know, times like these. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. This is a weird thing I did here. Oh, no, it's not. Oh, right. It's like I said before. We've got a string literal, and we're trying to make changes, which we're not allowed to do. So it shouldn't be a string literal. We need an array. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there's something wrong with my syntax. I don't think it likes this. So I need to Google how to make arrays in C, because obviously I've forgotten. I love how it autofills. F you, Google. Alright. Blah, blah, blah. Oh, right. Okay, curly braces. Okay, curly braces. My bad. I've been doing some Python or something. Python or JavaScript. Two, 3, 4, 5, 6, 7, 8, 9. Okay. And something's wrong. Okay. But at least we got some zeros in the beginning. So it was zeros. Okay. Probably we're having some kind of ASCII related problem here. We can try a bigger number. Let's just make the number 1 like this. 5, 6, 7, 8, 9. So as soon as we have numbers, it stops. Something like that. So that's going to be an int. So I think I just need to probably make it ASCII by doing this kind of thing. We'll just do this for a few of them. See if it fixes it for the first few digits. Yeah. But why is there a 0 in the beginning? That's confusing me. Anyway, we'll fix that later. Let's just do this. Oh, did I start with 0? No. It's finishing with 9. Wait, 1? What happened here? Between 1 and 3. It's missing 2. What's going on here? 1, 2, 3, 4. I probably made a mistake with the zeros. Number of zeros or something. I think it's here. Should have another 0 here, I think. Oh, made it a lot worse. What the heck? Should have another 0, right? No one in the audience to help me, please. Oh gosh, coffee. What's going on? We're close here. Wait. Here's the problem. We're jumping. Okay, we missed a whole thingamabob. All of these should have more zeros. Don't you wish your girlfriend were yeah. My camera didn't like that song. Alright. Does it go up to that many on in the array? Mod 10. We don't need that. Okay. Blah 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 blah. No, it's a 0 in the beginning. What's so? Something in my math is slightly off. There should be 1. Right? Hold on. This big number's not big enough, that's why. That's why. Okay, we'll put a 5 there. Now we're getting 1 to blah blah blah, but we're not getting the last number. So I did need the thing. So right now I have the last one is the 9th element of the array. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. 9. No, we need 10. If we're doing billions, we need 10. And so, yeah, now we just need to fill in the last digit. We don't need to mod anymore. It will be mod 1, which is just the thing. Wait, no, that would always, no. But I think it's right. I don't know how to, I don't have the energy to explain it. Apparently wrong. What's going on here? N equals n mod 10. Because I'm not looping through enough here. Okay, we have, it's printing the number. That's cool, man. We need to get push. Alias. Git push. Alrighty then. This is a little beastie. Now I've implemented this before, and it was probably, I think it was more elegant than this. This is ugly. This is ugly. But at some point I'm gonna do a lot of cleaning up, use a linter, organize things better and all that jazz. But I don't think right now is the time for that. Also, we need to handle negative numbers, technically. It's annoying. Very lazy to implement negative numbers here. Alright, I'm gonna rename this. And so I'm going to rename this, and it will remind me to fix it. It's positive. So put number probably works for positive numbers, nums, but not egg ones. Thus renamed. Blah blah blah. Cool beans, man. That was sort of satisfying. Curly braces on the erased. So what would the next day be here? So we have the next day. So anyone following along with this stuff, this program, they have their own linter called Moulinet, so you can find out how to run that. If you want to clean up your code, they have a style guide as well. It's good exercise, I think. It's good exercise. And if you look around, they also have testers for a lot of things. So you can find stuff that will test your functions, possibly. Create a function that takes a pointer to int as a parameter. Hopefully this is not going to be hard. Why did they not let me copy paste? Anyway. Oh, we can... No, you can't even copy paste that one. Void and then int star. Void int star. So it takes an int and then changes it to 42. Okay, it's a pointer to an int. I believe I cannot do something like... I believe I cannot do something like this, but I think I just need to do this. Anyway, how to test it though? Well, one thing I can do is just Google. Yeah, just star and equals 42. That'll do it. Then how to test it? We do a pointer to an int, call the function on the thing, and then print the thing. Print A. Okay. So this looks to be correct, but let's also test it, because I think testing, the fact that I didn't immediately know how to think of how to test it is not good. So int I equals, oh, they don't, okay, it's just uninitialized. Uninitialized. So the pointer, so when we do this symbol, it's like the memory address of something. So this will be the memory address where I is. So basically a pointer is an address, and it needs to be like this. This is a pointer of type int. Now the pointers are kind of all the same, but sometimes you can do pointer arithmetic, and that's where this type comes into play, because different objects have different amounts of different sizes. So yeah. But it's a pointer to space and address. It's basically an address in memory. So this will get the address of I in memory, and this will assign that value to this variable, ptr, pointer. So then all we need to do, we're going to need, I'm not sure if I've included this for printf, standard io.h. So we can printf actually I. We just get the value from I. So for example, if we said I equals 3, and then we also need to do this. It takes a pointer, so it's going to receive the pointer, and it's going to change the value at that address in memory. This will change the value. So I think when you start out with pointers in C, some of the syntax is a little confusing. Partially, one of the confusing things they do is that the star symbol means two different things. Here it's used to declare a variable that is a pointer. Here is just totally, completely different thing going on. And even here, this is a declaration of the argument. But this now is totally different. This means the value that the pointer is pointing to. So I think there's a few reasons why pointers are confusing. The thing is, like, once you learn them, there's nothing really confusing about them. They're kind of simple once if you get past the point of confusion. They're really not complicated, and they're rather powerful, so it's good. It's good stuff. But that's one of the reasons that they're a little confusing, because this star syntax has been used in two totally different ways. 3 if you count this as something different, but I don't think that really counts as something different. Okay, and so it should be changing the value of I. Let's test. I'm still getting used to this keyboard. There it is. So that works. Alright, that was fun. I'm just going to close out some of these windows that I don't need. Alright, that was that one. Ultimate. Create a function that takes a pointer to pointer to pointer to pointer, blah, 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 blah. Oh dear. So the same thing as just nesting all the pointer shenanigans. Why won't they let me copy paste this? One second. Let me download this. 1 second. Now can I copy? Now I can copy paste, I think. Okay. Let's just change this, and I think all I do is just put that here. But to test it, do I need to... How to test it? Do we have to do this? Maybe... Do we do it like this? How many is that, by the way? It's 9 layer? 9 deep. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can we just do like this? I don't know. Good exercise. Does not like that. Okay, I'm gonna cheat. FT Ultimate. I think it's okay, but I think just testing it is kind of a pain, I think, maybe? Yeah. That looks to be the thing. Yeah, to test it, you have to do this crap. Alright, I'm going to copy paste that. Pointer 9, and then A. Okay, that works. Next. FT swap. Create a function that swaps the value of two integers whose addresses are entered as parameters. Let me get a little more coffee. I'll be back. All right. I kind of remember this one. Nice, I can copy paste it now. Let's clear this stuff out. We don't care about that anymore. That's just an exercise. Okay, so little note about C. This is a declaration. The semicolon, remember, that's like a period. But what we want is a function definition, which is this, no semicolon. And we put stuff in here. That's a function definition. It just tells us what the function does. But kind of important to pay attention to that little semicolon when you're copy pasting stuff, depending on what you're doing. So why would you want a declaration instead of a just having definitions all the time? What's common, like you can see this files are getting pretty long already. It would be common to declare all your functions up here. So if someone comes and reads your code, they can see like, okay, we've got a factorial function. We have a get permutation function. By the way, this is just work in progress. And they can just see, oh, you have these different functions. And that's kind of nice, having the declarations. It's also useful when you make header files. So we've got a header file here, and it just contains the declarations. And the way that works, well, I'd have to explain about header files and how all this stuff works, and I'm a little lazy to do that right now. Another thing, you'll notice there's quotation marks here and there's angle brackets here. This is when you include something from the standard library, or well, this will look in a specific place on your system for these kinds of header files, like standard library and that kind of stuff. So if you download a library, you can put it in the same area, and it will look there when you use angle brackets. The quotation marks that will look at some path, and it will look, in this case, it's looking right here in the current directory. So for example, I could do like home users uv / but this would be terrible because if I use this on a different computer where the header file's located somewhere different, it's not going to work. So that would be a terrible way to do things. We could also, for example, we could make a directory with headers. This is a very common convention. And put the header file in there, and then we would need to do this here. So it's just relative to the current directory when compilation is being carried out. I think that's how that works. So yeah. Random notes. So we're gonna do swap. So the idea is just to swap these. I think, if I remember, there's like an elegant way to do this, but sort of more straightforward would be to have a couple temps. We need one temp at least. So let's see. Let's make an int star called temp, and then so we're just swapping these two integers, ints, but they're given to us as pointers. So let's set the first one equal to... actually, I think we'll just make this an int. We want the value at B. That's going to be this. The address at B would be this. I want the value at B. And then, so we have the integer value that was stored at B. Remember, B is an address because it's a pointer. We'll call this UV swap, by the way. And so we've stored that. So now we can delete whatever's at B by saying whatever is at B is going to be assigned whatever is at A. So we're still storing the original value of B, and then we can say whatever is at A needs to be that. And I think this should be fine. How do we test it now? Testing sometimes, that's really key. Always test. So it's void. So we're gonna have and let's say whatever's at A equals 4. Whatever's at B equals 2. Now we pass in these pointers like this, and then we'll printf some stuff. Let's do that in a second. Let's do... So hopefully we're swapping them, and then... So let's make this 2 and 4. We're swapping them and then printing. Segvault! Let's make sure that it's because of what we think it's because of. No, oh, it's still segfault. What's going on? Okay, we haven't... Okay. These are pointers, but they are not pointing to anything. And then I'm trying to set the value. So let's make an int p, an int q, and make this the address at P, make this the address at Q, and now it should work. Because before, without this, without this, yeah, when these were just being declared, they're pointers, but they don't point at anything. So when I then say, take the value that is being pointed at and change it, well, it's a pointer, but it's not pointing to anything yet. It's not been initialized. So as soon as I say, take the value that it's pointing to, the program or the compiler goes, I have no idea what you're talking about. Seg fault, screw you. So now, hopefully this doesn't seg fault. Let's just test that. Good. And now let's actually do the thing and see that it gets what we expect. 42. All right, so that's doing what I expected. I'm curious. I think there's a more elegant way to do this. So let's Google an implementation. So that's 4 lines, but they're declaring temp equals thing, thing equals thing, thing equals temp. Yeah, it's the same exact thing. Is there a faster way? Probably not. Maybe not. Just very curious about this kind of stuff. No, everyone's doing it the same style. All right, whatever. It's good enough. So that's swap div mod. Create a function ft div mod prototype like this. Sorry, I bumped the mic. Is my mic loud enough? Hopefully. Oh god, a bunch of shenanigans. This function divides. Is that all? Okay, that's all. This function divides parameters a and b, a by b, and stores the result in the endpoint unit. Okay. So we're dividing and we're getting the remainder as well. What do you call the quotient, right? The quotient is the result of division. So this is really a quotient. I don't like that they call it div. They should call it quot or something. Because div could be, when I see div, I think dividend or divisor. Is that the correct nomenclature? Anyway, the results in the int pointed by div, so that's the quotient. And then the remainder is in that pointed to by mod. Okay, so I can copy paste this. This should be really easy, to be honest. But I kind of enjoy this. Kablam. UV. Take out this stuff. UV div mod. So what's it going to do? We're going to divide them. So the address at div, or sorry, the value that it's pointing to is going to be a divided by b. Let's just make sure it's a divided by b, not b divided by a. Divides a by b. Yeah. Divides a by b. Good. And this is going to be it. That's it. I mean, that's really simple. So let's just make sure let's just cheat and make sure I didn't make a stupid error. Yeah. That's it. Easy. Easy peasy. Blah, blah, blah. This function divides a by b. The result of this division is stored in the int pointed by a. Oh, it's just more concise. So for this, we would just have some temps. This is really boring. We don't need to do this. Just store the values somewhere else and then blah, blah, blah. It's easy. Okay, put strings. So now we're getting into strings. This is going to be where it gets a little more interesting. Let me just see. Are people still watching right now? Let's check it out. Anybody out there? Wonder how many views we got so far. It says 2 people are watching. And no likes today. So sad. We got a couple subs. That's nice. Thanks for the subs, everybody. And we have 92 views so far. Cool beans. Let me use the restroom. I'll be back. So, put string creates a function that displays a string of character on the standard attribute. Here is how it should be prototyped. ft. So it displays a string of characters. Okay, that's actually going to be trivial. Screw that one. We're going to need... I think we can do it with this, yeah? unistd.h. We use right, no? And we want a length of string. I want to get a length of string. I'm going to implement it myself. Because we are hardcore. Int uv strlen. Int I equals 0, while, I'm not sure if we need I. Let's call it count. Let's call it len. While, and this is a first for the channel, we get to do that. Unless I'm mistaken. Let me think here. think that works. I think we just go like this, right? No, we go plus. So we start with str will point to the beginning of the string. In C, the end of a string always has 0 there. Not the char 0, but actually 0. Null. So when we get to the end of the string, it will become 0 or null, and then it will exit the loop. So all we do here is we increment len, and then at the end we return len. I think this works. I'm going to put this in parentheses. Doesn't really matter, it's just a convention. So I think that works. We'll find out if it doesn't. We'll find out because things won't work correctly. Okay. But I'm just thinking, we don't need to do all that. We don't need to do that. We basically do the same thing here that I just described. str++. Note that if we receive a null string, this will not run anyway. And we're going to use the write function that we get from this header file. Something and then 1. And is it just this? I think we need actually the value here. Is that going to work? Maybe. Well, we can easily test this. Might be a bug or two. Let's see here. Ooh, baby. That's a bug. We don't want that. What's going on? Do I have to do like, does not equal... something like this. I think we need to do like that. Well, I think it's the same thing though. I don't think that changes anything, to be honest. Wait, isn't it? I think it's supposed to be this. The value that's at that the thing is pointing to. I think maybe. Yeah. But write takes... No, write takes an address, though. Write actually takes an address. I don't know what's going on. I'm lost. Oh, yes, I forgot to dereference the pointer. Yes. That actually would be a problem up here. I do this mistake a lot. I'm very naughty like that. We just have to put a star here because it's the... Sometimes this bug makes me waste... I put this bug in there and I've wasted like 2 hours trying to debug this kind of thing. It's very naughty. Yeah. Because the pointer itself is... As long as something crazy isn't happening, this is always going to exist. It's always going to have some value. We need this. It checks what the pointer... It checks the value that the pointer is pointing to. And now I think this might work. Hopefully we don't have too many bugs now. Right. Oh dear. Alright, I'm going to do some sanity checks. A string equals some stuff. This looks like sad. That makes me sad. How about that one? That's better. And just total sanity check. I don't even know why I'm doing this, but... something about string literals. Yeah, that's fine. And suppose then, if I put S here... yeah, we get some shenanigans. What's going on here? So, alright, let's just work with one character for now. So, G. I don't think we need a star here, but let's test that. Just a Hail Mary there. Yeah, it's not right. Pointed from integer without a cast. Can I just use my put char? Do we still have the put char floating around here somewhere? We have it over here. Just copy it in. Too lazy. This should work, I think. Str. Char star. Yep. This is working. Why wasn't it working before? Why wasn't it working before? Let me check the man for right again. Const void buff. It's just a pointer. I honestly don't know. It's working now, but why wasn't it working before? Anyway, let's look up an implementation for this cheating. They have their put char and then they use put char. That's the same thing I'm doing. Why not skip put char and just use right? Not that it matters. Doesn't really matter, but can we get another at str with the thing? Ah, interesting. So this would be doing what I said. That's another way to do things. Okay. Some other ways of doing things, perhaps. That's the same way we just saw. Canale Italiano. I just want to see. I'm curious how many subs and stuff they have.
We have this time to...
They have 6K subs 2 years ago. It doesn't show the date for the shorts, huh? If somebody stop it immediately. 6 months ago. Okay. They've been somewhat inactive lately. Sad face emoji. Well, 4 days ago. 8 days ago. They're not inactive. Very different performances with the Fibonacci sequence algorithms and C. That sounds interesting. I'm gonna check this person's stuff out later, I bet. A bad intro to strings in C. Some interesting stuff. Alright. So again, I'm just curious why that didn't work, what I was doing before. So it sounds like if I do this, str, well, they're using I. I'm just still not sure why. Oh, just str by itself? It is a pointer. So you don't need the, yeah, okay, it's just a pointer. So I wouldn't need this. I think I was writing it like this. This would give me the address to the pointer. So this gives me like a pointer pointing to the pointer kind of thing. It is itself a pointer, so we should be able to just have that there, I think. Let's test it. It's working. Cool. Yeah. I think before I had it like this. It's unnecessary. So I actually prefer, compared to the implementations that we saw online, I think this is far more elegant. Yeah. I think so. It's like 2 lines of logic, whereas these other ones, I think I closed them out. Mine's more elegant than this. I plus equals 2? Plus equals 2? What? That's weird. That smells wrong to me. I don't know what's going on there. It's a conspiracy. Yeah, these are perfectly fine. Mine's more elegant. Hooray. This is more elegant. Okay, whatever. So let's put str. But technically we gotta check here. Allowed functions is none. So right, oh sorry, this is the wrong one. Allowed functions is put char. So we're not allowed to use right. So we do need to switch it out to put char. I was just curious why this wasn't working before. Now I know why. And str, it takes an int. So we just have it like that. Should be fine. That's working. Cool. Now it's fine. And we don't need this anymore. That was for right. Well, actually, hold on. This is needed up here. I mean, the order doesn't matter for that. It's up here, that's why. It does matter, yeah. But I don't think I used it in that function. I am using it. Alright, that's why it still worked. Alright, whatever, salad. So, let's just check I didn't mess something up. Good. I'm gonna rename this UV. And we'll just do good enough for me. think I got it wrong. No, I got it. All right. What's next? This is fun. Let's put str. String length I was just doing. Did I delete it? No, it's here. But I made the same kind of mistake here. This should be fine. Rather than testing it, we're going to test it later because we're going to be using this a lot. I'm just going to quickly Google an implementation and just check. I mean, you should always test, but I'm going to be testing this later. So let's just make sure we didn't mess up too much. This is basically an int. We'll talk in the future about what exactly that is. So I equals 0, plus plus. Oh, they're doing that kind of method. That's fine, but okay. I realistically, no, wrong button. I should test this. I should test what I wrote. So let's just test. So it should be 4. I might be off by 1. That happens a lot. Off by 1 errors. 4. We got it right. That's looking like it's okay. Let's just test for a null string. Oh, I pushed the Windows key. Hold on. Null is working correctly. Let's also test string of zeros. 3. Cool. Seems fine. Okay. Okay, reverse a string. Create a function that reverses the order of characters in a string. Has to return str. Why not? Why not do that? You know? Why not? So it's going to reverse it. Now, we don't have malloc, so, I mean, I'll double check that, but I'm quite sure we don't use malloc at this point. Allowed functions, none. And malloc would be inefficient. Because sort of the naive thing to do here is, like if we were doing JavaScript, make a string and then just do the thing. Just take the end of the other string and, like, character by character, create it. But this making a string thing requires memory. So one does not just arbitrarily make strings in the C programming language. That would require malloc. We don't have malloc. What the hell is all that noise? What are they doing? It's like a tank rolling by. I'm literally shaking. That's a huge truck. Alright. Okay, so what we're doing is we are swapping the beginning and the end simultaneously, sort of. So, the confusing thing is that it slightly works differently for when the length is an even number versus when the length is an odd number. At least when you first think about it. And so I'm going to think about something of an even number length to start, because that's kind of simpler mentally. But I think what we'll find is, in the end, our algorithm will work. The last one, if it's odd, we'll just get... it'll work out, I think. let's just think about even length strings for now. So naively, hold on. Should I use string length? It kind of slows things down, but it's going to be more intuitive. Int len equals str. Get the length. And then we will decrement the length. But we want actually, we need to do this for half the length. So it's a little bit sloppy, but we'll just do like that. And I'm going to have a temp variable. So let's clean up the code a little bit. Let's go like this, and then, sorry, like this. Here's our temp. What is all this shenanigans going on the bottom right? Whatever. So we're gonna say str. Okay, the value at str. Do you see this? You don't see this. As I'm typing, there's this thing in the bottom. Look. See how that? It's like processing all this crap. It's kind of annoying. What is that about? Just stop Windows. Even just clicking does it sometimes. It's freaking annoying, man. What is it with everyone who's not me, who isn't bothered by like pop-ups and little annoying crap like this? Oh, cameras that stop every 30 minutes. I know there's other people who are annoyed by it, but I'm one of those people. I hate pop-ups. I hate little distracting things that happen constantly. Really annoying. Fuck. Just stop. Just stop freaking VS Code. It's bothering me. Whatever. I'll try to forget about it. I typed random letters and it typed sad. My God, is that a Freudian slip? Oh, that's really annoying me. All right, I'm gonna switch to Vim because it's pissing me off. We'll just leave it like that. Fucking VS Code. Fuck you. Switch into Vim. Fuck VS Code. All right. So it's going to be something like len minus, we need an iterator. Wait, do we? We need an original length. The original length, I'll denote like that. Oh God. Len original equals len. Len here is the iterator. So this is confusing choice of variable names here. Just don't care right now. Len minus len. So we're going to find out a lot in testing. It's very easy to make all kinds of off by one errors with this kind of shenanigans. But I do need to also... Actually, just as an iterator, using I and J is kind of better. Where we're sort of iterating from both sides of the string. So let me change it like that. I think it's more straightforward. So length is not going to change. We're going to have I. We're going to have J. Oh, we need half the length though. Ugh. Okay, I'll accept that. We'll have half the length thing, so it does change there. And we have I and J. So... Oh, you know what? No. This will be I. Wait. Yeah. Then while I, and then we decrement I. So this is len minus I, which I'm going to say is J. So I'm going to say J equals len minus I. But we still need... Oh yeah, it's okay. Len didn't change. That's good. We don't want length to change. That would be kind of weird. But we're decrementing. I is not working. Okay, so here we'll change it so that I increments. And we have I is less than length over 2. Let's do it like that. Then we don't need this. So I is incrementing now, and J is length minus I. That's good. Good. Do we increment str? No, let's just str of I. And here, strj is going to be stri, but we've changed stri, so that's why we have the tmp thing. One thing I don't like is that when you see tmp right away, you don't know what type it is. I don't know. It's a minor quabble. But here we go. All right, so let's think about this. We're setting the temp variable to whatever is at I. This might work. it might work. I don't know. I kind of doubt it, if I'm being honest. Can I copy paste like this here? Probably. So I don't have any mouse scroll. Not a big deal. You can add that. I'm not sure with WSL. You probably can. Do we need this? No, we don't need that. Oh, actually, we want to see the order. So, and then actually, though, we want to do print F. So be S. All right. Multiple definitions of put char. Oh, I really wish I had the mouse scroll. Let's see if I can fix that. WSL vim mouse wheel, mouse scroll. Huh. Wait a second. Wait, what? Mouse scroll doesn't work in WSL. Does this answer your question? Hitting arrow keys adds characters in VI? Why would that answer their question? Anyway, set mouse equals A might be something to try here in the vimrc. So I'm going to try that. See if that works. Oh god, the tilde key. How do I do tilde? I always forget how to do tilde. Alright, actually, I don't think I've learned how to do it on this. I have this Japanese keyboard. No, not that. MRC. Okay, we've got mouse scroll. Cool beans. Should I add my vimrc? I'm gonna do something a little weird. I'm gonna copy. Oh god, the tilde key. How do I make the tilde key? How to tilde on Japanese keyboard. You have to press it. You have to press it twice. Ah. So I'll try Control or Alt. That's not working. Separate, unrelated question, but why use a Japanese keyboard? It's just the button below escape. I don't think that's going to work for me. Let's try. I mean, that's the way that it normally is on a keyboard, huh? No, that's not working. That does something else on this keyboard. I don't know how to use the tilde. Hooray. /.mrc. Whoa. Oh god, something weird has happened. Well, I think it was on German or something. Anyway, I'm gonna copy this to here. Rather than do a separate repo, I just want this in my repo. I just want it available in the future, my vmrc, because I don't want to have to figure that information out again. Whatever. So we're trying to, okay, so gcc main.c, we have some error, seg fault. Oh yeah, I'm feeling really lazy. I kind of want to look at an implementation. Temp equals a thing. And they're decrementing length also. That's kind of nice. I like that. What just happened? Oh. Right, it doesn't... Wait. It's possible that I'm testing it incorrectly. Also, it's... Yeah, okay, never mind. Wait, what the hell is going on with my keyboard? Yeah, I got a mistake. So they do the string length here. So the idea is exactly the same. I just have some silly mistake in here. Are they returning? Yeah, they're returning string. So... Hey, Korosh, how you doing? What's up? Just doing some C stuff. Got the string length implementation. Should be fine. Okay. And we're just making a function that reverses a string. I have some kind of mistake in here. It's giving me a seg fault. I don't know how far along on your programming journey you are, if you know what a seg fault is. It basically means that the program is trying to access memory that is not allotted to the program, right? The operating system allots a certain amount of memory to a program, and if your program tries to access memory outside of that, that's a seg fault, segmentation fault. This is causing a seg fault for some reason. Yeah. How far are you with your programming, by the way? I think you were studying Python, was it? Could be wrong. Okay, you didn't know that. Yeah. I mean, normally you only learn that if you study C. That's where most people know it from. Most languages cannot seg fault. Yeah, because in C you have pointers. Pointers point to addresses in memory. Your whole program runs in memory. And yeah, so pointer points somewhere in memory. And C uses pointers. Actually, all languages use pointers. They just, like the higher level languages, they use pointers under the hood. They sort of hide it from you. And one of the reasons for hiding it from the programmer is to avoid things like seg faults. It's a very common error if you're doing C programming. So let me work through this logic a bit. Yeah, I was learning Python in the summer, but now college is kind of annoying. Oh, really? College, oh, you know some C++, yeah. Are you studying C++ at college? Or are you doing a bunch of stuff that's not programming? Or was it you? Wait, were you saying that you were going to study to become a doctor, or are you doing computer science? Okay, so I equals whatever value we had at J. We not, I don't initialize I. That's weird. I think it would initialize at 0, but we should initialize. And then J, I don't need to initialize. It's getting set in the loop. All right. Wasn't you. But what are you, have you decided what you're studying in college? Are you doing computer science? I don't think that was the problem. If I can't find anything else, I'll test it. Usually I think this is going to initialize to 0, but you probably, I don't know. Maybe not good to assume that. Length equals the string length. Okay. While I is less than length over 2. J equals length minus I. So right here, I think if I was not initialized correctly, then this J would have pointed somewhere else. That could have caused a seg fault. String I, so we're swapping that one. Yeah, let's test. That might have been the problem. Not sure. So I'll compile, run the binary, the executable. No, still, that wasn't the problem. Computer engineering. I'm going to go for master's in AI. Cool. Yeah. But if you're majoring in computer engineering, I mean, you're going to need to know at least a handful of languages. Yeah, there is this. So there's a school called 42. They started in France, and they have a bunch of schools kind of all over the world now. Not in America though. But anyway, I'm using their curriculum basically, and you can find it just by searching for like 42 PDFs. So the piscine, that's in French that means pool. So the idea is that's the beginning, the first month. The idea is that you're jumping into a pool, getting started. Yeah, French term for pool. So you can get the beginning PDFs just by Googling it, and this was the first result. The first 2 days here are just shell, just terminal stuff, and then on day 2 it starts with some. Should start with C. Yeah, and actually I started here today with print alphabet. So I skipped some of these. I did most of put number. Put number, I implemented a function that, so it just takes an integer and then prints it into the terminal. And I did an implementation, but it only handles positive integers. I was too lazy to bother with implementing the negative integers as well. And I skipped a couple of the others. And now I'm on day 3. I did most of these, and I'm on string reverse here. And the next one is A2I. A2I basically takes a string, I forget if it's a character or a string, and outputs an int. Let's see, I have the PDF right here, so oh. Yeah, it takes a string and then outputs it as numbers. I cannot study with documents to save my life. Oh. Yeah, YouTube videos are much better. Yeah. It's easier to learn. So if I'm trying to learn something complicated, yeah, it just depends on what it is. For programming, learning by doing and watching YouTube videos is probably the best. Like learning from books and stuff is hard. But this is partly what I'm doing here is learning by doing. So if you wanna practice C, I'm like a few live streams ago, I did a live stream introduction to C. It's like an hour and a half. And then, to be honest though, I've done that first video, but I haven't done like what would be good as a second video. I guess today's live stream is the best thing as a second video, but honestly, it's going to be difficult to learn from. I don't really know who my intended audience is. I haven't done like a tutorial series, but there's lots of tutorial series out there, so I'm just having fun. But anyway, so I was kind of cheating and looked up a implementation here. Where is it? Here's an implementation. I don't know why mine is segfaulting though. It is conceivable I have an error with my string length. I'm gonna print out more information. I closed VS Code. Let me bring up VS Code again. Hold on one second. It's kind of adding subs above talked videos, reinforcing learning. Oh. You're talking about subtitles in videos? Hello, Music Song. Welcome. And Deuce, welcome. My ADHD level is too high to be able to study with document. It's really hard to learn programming just from reading a book. I mean, that's just hard. Like, I'm really good at studying things, I think, because I think so, because I'm actually happy just reading a math book, like reading a math textbook, which I think most people would struggle with probably. But I would not try to learn programming from a book. I mean, once you already know how to do, once you're already like pretty proficient with a language, then using some books, checking some books can add to your knowledge. But it's really hard to start out learning that way, I think. Music Song says, I know Python and JavaScript only. Okay. Well, most of those languages, like particularly JavaScript, for example, they're kind of, the syntax is sort of inspired by C. C is kind of one of the OG languages, right? So just having semicolons at the end, for example. I don't know if C was the first to do that, but I think JavaScript is taking inspiration. I mean, this is kind of close to JavaScript. Sorry about the camera. This is kind of close to JavaScript code, actually. But there's some big differences with C. Like that. The biggest thing is that you have to be very specific with memory management, which will come up here. Let's see what I was working on. Yeah, I have some kind of problem with this function. We're trying to reverse a string. So if you're trying to reverse a string in JavaScript or Python, you could easily just make a string and do it. But now I could do that. If I were doing that in C, I could use malloc. See, like when you create a string, you need to create memory, right? So something like Python or JavaScript kind of does that for you easily. But in C, you need to explicitly create the memory. So I could use a function called malloc. And for example, here, I'm getting the string length of the input here. So I could say, I'll make a new string. So that looks like this. New string. And we create a number of bytes with malloc, and we can make it the length. And this would be fine. But this is less efficient. If I can reverse the string sort of in place without allotting new memory, it's more efficient. And in the sort of curriculum that I'm following here, I am not allowed to use malloc. And I think it's a good exercise to reverse a string in place without allocating memory. So whereas in JavaScript or Python, you would probably automatically do something that is less efficient, C is kind of forcing you to be aware of what is actually going on at a lower level. And yeah, creating a new string with malloc is going to be less efficient. So I'm trying to avoid that. That's the exercise. And I've done this before, but I don't know. For some reason, I'm getting an error, a seg fault. Which, for people just coming in, a seg fault means that you're trying to access memory that you shouldn't be accessing. So what I was going to do is make sure... So I'm going to use print statements to... print statements to get some output here. In Python, I think there's a function for reversing a string. Yeah. There probably is in C too. The point is to implement this stuff oneself as a form of practice. Yeah. C was from error when memory was counted by a few bytes. Yeah, I mean, C is still important if you're doing like people who write operating systems use C generally. People who write drivers, anything where you need really explicit low-level control, you probably want to use C. Or if you need things to be extremely efficient, I mean, it's not like you have to use C, but I think C basically is really conducive to kind of forcing the programmer to write efficient code. It's not a guarantee that they're going to write efficient code just because they're writing C. And also, with some higher level languages and other things, you could potentially write pretty efficient code. I mean, generally Python is going to be slow. Now C++, if you really know what you're doing, you should be able to be just as efficient in C++. C++ is almost a perfect superset of C, meaning, it's C with more stuff added. But that's not exactly true. There's some small exceptions to that. But, I think the reason that Linus Torvalds I think all his projects are in C pretty much. I mean, the Linux kernel and all that. And I think part of that is just forcing people to... I mean, he does not like C++, which is interesting. C++, I think, is kind of a mess, to be honest. The creator of C++ himself has said that the problem with C++ is it's too complicated. So Linus Torvald has said some very nasty things about C++. But kind of all the languages kind of suck in their own way. That's basically... There's no perfect language. They all suck. With C, the thing that sucks is... in a way, you have less power. You have to manually do some things that other languages would just do for you. I mean, C technically is simpler in a way. It's hard to say. C is technically simpler, I think. But you can write C++ code that is basically just C. So let's say I were planning to write a game engine with a few other people. So if I were doing it by myself, well, actually, let me think. I don't think it matters, by myself or with a few other people. Using C++ so that you have classes built in, because C does not have classes. You can still do kind of the same thing, just using structs and pointers. You can basically do object-oriented programming with C. It's sort of there's a common misconception that C has no object-oriented programming. C does not have classes, but anything you can do with some other language, some higher level language, you can do in C. It just might be more complicated to write. But yeah, so it would be kind of a pain in the neck to do like object-oriented programming where you have inheritance and polymorphism and those kind of fancy things. So if you do C++, you can have access to that kind of stuff, the object-oriented programming stuff, without having to implement it yourself, which is probably a pain. The downside is that C++ opens the door for a lot of complicated stuff that people can do, which if you're doing something complicated like implementing a game engine, I think it's okay having tools like templates and that kind of stuff. But What you might commonly see is like someone who the person who wrote Doom, the founder of id Software, Carmack. Is it John Carmack? He says use C++ for the classes, but basically write C++ like it's C. So he's saying keep it as simple as possible. So I think you might see that kind of stuff. Also, I think a lot of people use templates. Templates can be useful. Also, funny way to program is build mathematical equation and run it. There's a language designed for designed with that kind of idea in mind, where you have like a close correspondence between mathematics and code. That's sort of, it's more of an academic kind of thing than something that's used in industry. I forget what it's called, but I think it's really interesting because I like this kind of stuff. What's that called? Language that connects math and code. See if we can find it. Dang. Natural language? No, I can't find it that easily. It might come up here though. No, they're not listing it. We basically learned C under the cover of learning C++ in college. No library usage. No oop. I see. That's not a bad way to do things in the beginning. Hey, can you recommend any source to learn some advanced C++? Oh, welcome, Batman. I'm good in C++. Just want to get... I mean, my recommendation would be to do leak code stuff, you know. Have you done leak code? People are padding their resumes with leak code stuff, so you can go in here. I'm guessing you've heard of it, but if you haven't, I would recommend going in here, and there's tons of problems. You can sort by difficulty, build up your skills, and that's good for your resume as well. I don't remember the name. Fallen. There's a PHP package, PHP framework called Falcon, but I don't think that's what you're talking about. What is that thing with related to math? Where was I? Here. So we'll look at some of these, but this is not what I'm looking for. The question is, what programming languages do mathematicians use? First person's talking about Python. Definitely popular for mathematicians and scientists to get stuff done, you know? Haskell, yeah. It's a functional language. Mathematica, I don't know. I don't really know about Maple. But there's an interesting... Lisp is interesting as well. Lisp is pretty different. R is for statistics. MATLAB, Mathematica are the main ones for mathematicians, yeah. These are math-focused. Haskell is very popular for category theorists, yep. I don't really know about PostScript. I like studying assembly a bit, knowing how to do things at a lower level. Don't know much about OCaml. Mostly use C. Yeah, I think before Python became sort of the lingua franca in the science world, I think it was C for a while. But you'd have to go back maybe to like the 90s. But there's still professors who use C as sort of a lingua franca. You know, like scientists and that kind of stuff. Still not finding the thing I'm looking for. But I think I might find it on YouTube, actually. I think it has to do with this stuff. This guy, Leslie Lamport. This is stuff I'm looking for. Hello, Karun. How you going? How you doing? How's your day? Huh. This guy created LaTeX, is it pronounced? LaTeX, I think it's pronounced. But what language are we talking about here? I think this is it. Is this a TLA plus? Not sure. I might be thinking about something different. I think this is it, actually. So the idea is that you have a language that where if you have some math, you can represent it in the programming language directly, and so you can check things mathematically and make mathematical proofs. For example, that your program is going to end, or within a reasonable amount of time. This kind of stuff. But I'm not totally sure that I've got the right one. I might be thinking of something different. Adding math and physics, you can use programming in real-world applications like controlling. Oh yeah. So embedded systems, usually they're going to use C. It's not a rule or anything, but I think that's the most popular. Rust is gaining traction, but I'm not sure if they use it in embedded systems too much. Embedded Rust. Where are we today? Have you heard about Rust? Oh my god, is this like an AI generated shenanigans? This feels like a bad article. God, get to the point. Embedded systems. It says yes in small pockets. That's what they're saying. Established teams are not adopting Rust. The thing about Rust, like the learning curve is crazy. Rust is the only language where I've spent a fair amount of time and I still don't get it. Rust is the most complicated, difficult language that I've ever studied. So I just don't get it. I want to understand it. But also, there's this YouTuber, Prime. He was kind of about Rust for maybe a couple of years, but now he's like, Rust is too complicated. Forget about it. So I've kind of just watched from afar what he's doing. The bottom line, yeah, Rust is too complicated. I want a language that is similar to C, a little more powerful than C, but trying to keep things sort of simple while also giving you the option for low-level control, like with malloc and this kind of stuff, and use of pointers, for example. So powerful like C with a few added features, but then one of the main points of the language is to keep the learning curve as short as possible, to make the language as approachable as possible, so that it could be used by scientists, mathematicians. I just want that kind of language to exist so that I could recommend that to people and be like, this is a good language. The only kind of complicated thing, I mean, pointers and memory allocation, this kind of stuff can be sort of complicated. But if you had a little more power, you could actually, you could, like, there's some languages, I think, is it JavaScript, has like a using strict or something that you can put at the top, strict. Oh my god. Is that what it is? Strict mode, JavaScript, use strict. Yeah, it's just quotations use strict. So you could have something like that where if you don't have that, then you don't have access to, like it would say, for example, using advanced or something, okay? And if you don't have this, then you have dynamic memory management, and the language would work actually closer to like JavaScript, where you don't, you're not worried about this like extremely detailed efficiency. So it'd be, at that point, it would be just easy for people to use. It's kind of like Python. But then when you do this, then you have low level power using malloc, and you have to be, maybe you could also maybe having I don't know, maybe it's going overboard. Maybe you could have like using strict advanced, which would you want to do that? Maybe not. Maybe just advanced. Then it would act like more like C with more low level control. I would like something like that ideally, but alas, I do not get to dictate everything in the world. Things with more motors, its torque needs to be controlled, so it doesn't. Yeah. So it needs to be interpolated. Hey, Milk and Cookies. Yeah, I'm still here. Am I professional? I've worked at a few companies. I've never worked at a company doing C. Done more, mainly like JavaScript, but I don't have a huge amount of experience with companies, so I don't have like a real good career. But I've done programming for maybe like 10 years. Mainly, most of the time it's been as a hobby, sometimes with companies. Sometimes getting paid. So, back to this. Honestly, if I just rewrote this, I probably would fix the problem by accident. I don't know why I'm getting a seg fault. Why are we getting a seg fault? Let's just confirm that we're still getting a seg fault. Yeah, I think we're still getting a seg fault here. I'm just going to rewrite it. So this function is supposed to reverse a string. So if we give it s, it ought to reverse it. Okay, let's write it again. Okay, let's implement the length check again. So we'll have a int length. Say length. We'll just initialize it at 0. Length gets incremented. str gets incremented. Okay. And we'll print something out here. So let's print out the length. Oops. Still getting, I changed my keyboard to a Japanese keyboard recently, and it's messing with me a bit, but it's usually the same as the US one. We want decimal. Let's make a new line as well. So right now this is, and we need a return. We'll just return str. So the length was 7. That's correct. Electric motors have insane torque. I love how it keeps like auto-correcting you. Insane torque if it revs max instantly. Yeah, that makes sense. Yeah. Yeah, you need to smoothly interpolate somehow. Some kind of function for that. That makes sense. So we're doing the length correctly, and now the string has gone up. So let's... So string is pointing to the end of the string now, str. If I say string, I just mean str. So while length, we'll decrement length. Let's have a char. Temp. So that's the backside of the string. But we are swapping the end and the front, so we don't need to do this for the whole length. I think this should work. No. Yeah, I think that works. Should be about half as much. So let's see. Wait a second. No, that won't. No, that won't work. What we need to do is, because when length is 2, this will still be 1. What's the solution? Okay, that will get us... We just need to iterate this, whatever half of the length is. So, TMP equals whatever is at str. Then, all right, let's do it like this. Sorry. Let's do it like this. Let's increment. If I haven't made a mistake, this will work, but I probably made several mistakes. Yeah, I almost certainly made several mistakes. Let's just see what happens. We get a seg fault, yay! All right, let's print out some information. Let's start by just printing temp. As a char. Doesn't like that. Yeah, printf, sorry. See, we use formatted print. What? I didn't save. Segfault. We're segfaulting before we even get to here. What? So print 7. Let's... Okay. After str goes through all of this, it's pointing to the null, the end of the string. So a string in C programming is a sequence of characters terminated with a null character. Yeah. So it's pointing to this end of the string that's the null character at the end after we compute the length. So this right here is going to be pointing to a null character, to null. Is that bad? Yeah, that's bad. So what we want to do is we want to decrement by 1. Now we're pointing to the end of the string. That may have been the problem that I was having before. Segfault! What is going on? Let's print out str, whatever is that str. Camera friend, back on please. What the heck? It's segfaulting here. Because it's printing the length and then it's segfaulting. Minus, minus, oops. Minus, minus should be decrementing str. I don't get it. How is that segfaulting? Let's do this twice. Well, I'm just getting confused. What the heck? I don't know what's going on. I'll be right back in 2 minutes. Bop, bop. Hello. Oh la la. Alright. I'm not so interested in, well, I want to know what I'm doing wrong, obviously. I'm not so interested in, hold on. I'm making a very silly and stupid error somewhere. So, I'm going to cheat and copy this. I just want to find my mistake. I don't really care about, like, going through the masochistic process of grinding it out myself. Done that too many times in my days. Oh, that's also seg faulting. Wait a second. So my testing is wrong? Is my testing wrong somehow? Or is their example code just also seg faulting? No, that works. What was going on here? The mistake was in here. Oh, wait. The only difference there is I was doing star S. Ah, of course. Of course. That's why. It's the same mistake. I was talking about this. I lectured on how you should avoid this mistake like 2 hours ago, and I've made this is the second time I'm making exactly the mistake where I'm like, be careful to avoid this mistake. This is a string literal. This is pointing to the data section of the program, and it is immutable. You cannot change this. So this is every program has 2 or 3 sections. One of them is data, and so this is an immutable string. So then we're trying to change the string right here. That will give a seg fault. Right. If you do it like this, that will create a string in memory. Okay. Good. All right. So yeah, messing around with this for longer would have just wasted my time. So let's go back here and see if my implementation works. Now I might still have some other bug. Do this. Now this is a mutable string in memory. Cool. And looks like it's not quite right. Something weird going on. Still have a little mistake somewhere. 9876, and it goes bananas. Temp equals a string thing. Oh, we don't need to do this. We don't need to print. Oh, probably just because we're printing this. That's why it goes bananas. Maybe. Maybe. It's not reversing. 1, 2, 3, 4, 5, 6, 7, 8, 6. Temp equals string. str count. Yeah. That's not the beginning of the string. That's still wherever str is. Wait, yeah. So let's make a... Let's make this... equals TMP. I mean this, and then also, so this is the front side of the string. The value that it's pointing to, we are going to assign with that. And that's why we have the temp, because we're overwriting this. So now we have temp. This might work, maybe, if I don't have more mistakes. Always possible to have more mistakes. 987654321. Seems to work. Let's add a 0, because odd and even is going to work slightly differently. And, seems to work. Seems to work. That's cool. I'm going to call this UV. Finally. Implements, what's it called? strrev. What is this weird operation not permitted, and then it just does everything just fine? Weird. Okay. Bro. It's 6:43 p.m. What do you expect, bro? I'm in Japan. Aren't you in India where it's like 3:15? FT at... okay, now we get the A to I. Hooray. A to I to A is harder. Let's do a little A to I. Start out with the same shenanigans. Like that. So we're getting the length. And str is also incrementing forward, which probably we don't need that. A to I. We gotta output an int. So for example, oops. For example, we're gonna have input like this number, for instance, and we need to output as a string. No, we receive that as a string, and we need to output it as an int. So let's add the output thing. Not sure. Do we need to get the length like that? It's going to be coming from the left. We had put number. So put number, my put number implementation was ugly. Did that earlier today. It's right here. This is my, and it's only doing positive numbers. Okay, I'm a little lazy. I'm very lazy. I'm just going to take a glance. Are they just using put number? A little more complicated. Right, because... what's all this about? End line? Oh, I think you're... yeah, you're supposed to avoid white space and stuff like this. If we look at the man page for A2I... does some weird things with white space, I think. Do we have that in, is that in the PDF? Oh, it says man it. It says to check the man page. What does it do with... Yeah, I think it ignores white space. Let's see here. That's all the info, huh? It says it's the same as this. Yeah, arbitrary amount of white space. Blech. So that's why they're checking for this stuff and just incrementing through it. Just ignoring it. They also deal with if it's positive or negative. Oh, wait a second. And this is... What's going on here? This is the clever bit, I think. So if it's in the range of ASCII digits, 0 through 9, then... Yeah, this is a very clever little algorithm. I remember when I first saw this, it took me 10 minutes of somebody explaining to me how this works. And it's one of those things where somebody's explaining something and you're not understanding. And you could just be like, oh, okay. You're like socially tempted to just be like, yeah, okay. All right, fine. But I sort of really wanted to understand it. So I was like, I'm still not getting it. Yeah, this is a little complicated to walk through in your brain. It's actually my favorite algorithm, probably, that I've ever seen. Very key. Goodness gracious. That's the one, huh? Okay. Yep. They're also doing the same kind of thing. Interesting. So wait, is that how people's put numbers are working? Put number. Yes, yes, yes. Oh, they did a recursive one. Yeah, but it's the same algorithm, just recursively. This is not easy. I know the title says easy C. This is no longer easy. This is almost everybody learns, if you're trying to implement this kind of thing, they just learn it from looking it up. If somebody sat down and had a big think and came up with this themselves, it's like that's at least semi-genius. And it's so elegant and simple. So, what do I do? Do I copy? I had this ridiculously stupid way of doing things. I mean, it's doable. Just incredibly not elegant. But we're not going to build the whole city just by ourselves. We learn from others too. So what should I do? I could implement it myself, just using the knowledge that I gleaned from glancing at other people's work. It's kind of a pain, even just doing that. So I might save that for another day. This is a little bit complicated. So what have we got in main? Also, everything needs to be really cleaned up, which I might do off camera at some point because I think it'd be boring for people. Like this file should not be 200 lines long. This should all be in separate files. I've been using this run.sh, which I'm perfectly happy with, but you could argue I should use a make file Makefile is a thing that people use. So those are kind of things to look at. So I'm going to write a little to-do file for myself here. Let me check the diff. Windows likes to add this crap. This is a Windows thing, these !m characters. That can actually cause problems. Oh, I don't even want to think about that crap. Just these kinds of things that you learn the hard way. So WIP. Okay, and then let's make a little to-do. Actually, for makefiles, I mean, you just grab an example makefile from online. That's actually nice because what's nice about a makefile, it's really for other people. Because you could do what I'm doing and just have a run.sh where you have your compilation step and whatever. You could just do that. The problem with that is that if somebody comes to my project, somebody else looks at my project, this is not necessarily going to jump out at them. They're not going to know what to do to build it. So a lot of people will come into the projects and they'll just go make. This is actually, you might go configure and not going to happen, and then make. Obviously that's not doing anything because there's no make file. These two steps are sort of the convention for installing something, making it work. So what's good about a makefile is that everything should in theory have the same process, but there's also CMake, which is another thing. I believe that came after make. It's a little more advanced, but the point is you follow some kind of convention so that people are not confused. And ideally you'd have a README and just say, this is how you run the project, like that. Or whatever instructions. For me, I could just have, hey, this is what you do. Right now, if I run that, we have an error. But if I do the stuff in the to-do, we'll fix that. We have a bit of disorganization right now that needs to be cleaned up. All right, so I'm going to commit the to-do file. I'm going to push it to my remote repository. And there we go. So if you go to GitLab, my GitLab, let me just log in. You have to, I guess you have to set up an account, huh? To look at it. Did I do the wrong? Oh dear. Just logging into my GitLab. Okay. So, theoretically, if you go to this beautiful URL, here it is. It should be public. So let's see, if I open up a new... Can I open it as a guest? Yeah, it wants you to log in. But it should be public if anybody wants to find it. GitLab UVC. Oops. It's not getting it. So, what I'll do is... I don't know. Right now you just gotta type it in the URL if you want to access it. And I think that's good for today, for now. I'll probably do some stuff off camera, just cleaning up, maybe adding a make file. And then in the next live stream, probably tomorrow, maybe, I'll probably have things a bit cleaned with a make file. Then I'll explain. I'll probably just copy paste the make file, make some small changes. I'll explain what I did there and how things are organized, and then I'll try to implement these just now that I remember how the elegant algorithm looks. It'll be a bit of a challenge, even though I know how it works. Anybody who's interested, just look this up. A2I implementation. Well, there's this stuff. But what you could do is type in 42, get these. You could look at the code here. Try to understand it. I think it's hard. I think it's really hard. Or just wait for the future streams. I'll try to explain it. It's a really beautiful algorithm that helps you to avoid what I did. What I did is ugly. This is what I did. We check if n is greater than 1 billion, and then blah, blah, blah. This is for put number. Well, right now it's only handling positive numbers, so put positive number. So this is not elegant. This is ugly. But it's also easier to understand. It's probably... I'm not sure. In terms of efficiency... I'm guessing this is less efficient, but... it's worth thinking about. Anyway, yeah. Need to clean up a lot of stuff. Organize... Got this nice factorial. Anybody, whatever language you know, it's a good exercise to write a recursive factorial function. Rather than looking it up, just try to write it yourself, recursively. And same for a power function. I implemented my own power function. I should have... This one also I could definitely do more elegantly. So I just looked for ftpow. This will do the 42 school. There's lots of people uploading their stuff. And look at that. That's elegant. Interesting. That's so concise. Amazing. But I doubt nobody's going to write this at first, right? Most people are going to write something like this. And then if you're extremely smart, smarter than me, you could do a deep think about what you're doing here and then write it in one line. Or you make a sacrifice to the gods and use ancient knowledge and write it in one line like that. That's cray-cray. I think at 42 they're not allowed to use this kind of syntax, actually. Let's see somebody else's thing. Oh, wow. Okay, they did it like that. There's lots of ways to do it. And that's it. Not a lot of stuff online. Interesting. But you could just do implementing recursive power function. Got some stuff on some videos. We've got Stack Overflow. I'm surprised. Yeah, I was gonna say there's probably geeks for geeks. There's a few ways to do this, you know. Problem is they always switch it to Japanese on me without asking. It's annoying. Switch to English. So here's using recursion. That's probably going to be more elegant. I'm not sure about more efficient. It'd also be interesting, this is more work, but implementing a few different algorithms and then trying to profile to measure the performance. They got a lot of different versions here. Using binary operators. I think that this idea occurred to me at some point, but I wasn't able to like finish the thought. I was like, isn't there a way to do this with binary operators? Interesting. But yeah, I didn't figure it out. I thought about it for like half an hour. It has to do with how things are represented. This is pretty cool. Ones and zeros, and there's a way to do it like that. Very cool. Well, using Python, this is like cheating. Because that just does power in Python. I love how it says, program to calculate this using the Python ** operator. And then it says C++. Implemented in C++. What? Oh, sorry. Python. This is basically cheating. Hello, Python. Hello. Doesn't want to switch. What the heck? That's weird. Daddy. Oh god, there's a lot of implementations. Yeah, it's good practice. So every once in a while you can come back and do factorial power in recursive with a recursive function. You can go to leet code. Where's my leet code at? Lots of things to do here. Get better. That one person, Batman came in and asked how to get their C++ advanced. I told them leet code and they disappeared. So maybe they just went to leet code. That's it for today. Thanks everybody. And I hope you have a fantastic rest of the day, wherever you are. Goodbye. Thank you.